Alrighty, welcome to my talk. Thank you to StirTrek for hosting me, and thank you to all of you for coming, especially the last session of the day. I'm sure you've been taking in a lot of good information today, and I appreciate you spending your last hour of the day with me. Today we're going to talk about observability and how it intersects with culture on software engineering teams. Before we get started, I'll share just a little bit about me. My name is Brooke, and I am a software engineer at Honeycomb, which is an observability tool to help software engineering teams understand what their code is actually doing in production so they can solve bugs and outages more quickly and effectively. I've been at Honeycomb for just over a year now, and I work on the APIs and partnerships team. So I work on our external APIs, our Terraform provider, and integrations with other tools in the developer ecosystem, such as PagerDuty and GitHub. Prior to joining Honeycomb, I worked for a Fortune 50 company where I worked on headless e-commerce websites, as well as IoT or Internet of Things. I was actually a Honeycomb user at that job and got really interested and passionate about observability when working on IoT specifically, because there is a lot of complexity there between orchestrating mobile apps, firmware, and cloud that really helped me to see the value of observability. When I'm not working, I really enjoy baking. Pies, cookies, and bread are probably my favorite things to make. So to start out, I'm going to jump in with an intro to observability. I think it's a term that can get thrown around a lot without everyone necessarily being on the same page as to what it means. So I just want to talk about that first to get all of us on the same page before we hop into the culture benefits that it can have. So I'll start with a definition. If you've spent any time at all working on observability, you probably know that defining it is one of the hardest parts. There are many different definitions of this word floating around, but the one I find to be the clearest is observability is a measure of how well the internal states of a system can be inferred from knowledge of its external outputs. So I like this definition because it avoids describing technical implementation, and it actually doesn't reference software at all. And that is because the concept of observability was originated and defined in the context of control theory and has more recently been applied to software engineering. But when you are thinking about the code base you work on and trying to determine if it is observable or not, I find this definition to be a really helpful guide to answer that question. I'm sure we've all had the experience of a bug report coming in or a system outage happening, and you have no idea what's breaking. And you look at your logs, everything looks normal. You add some console.logs or format.print lines to figure out where things could possibly be breaking. And you keep doing that until you figure it out and fix the problem. And then you probably wipe away a bunch of noisy got here, got there lines out. That is an example of a system that is not observable. You had to push more code to figure out why your original code was broken. In a code base with observability, your system consistently pushes out signals that let you know both what is succeeding and what is failing within your system. So now that we have defined observability and talked about its origins, let's talk about how it does fit into software. Observability is often shortened to O11Y or OLLY within our industry. This is a common practice we see with other examples like ALLY for accessibility and KATES for Kubernetes. I guess we just will look for any opportunity to abbreviate a word within our industry. But my slides do reference observability as OLLY later on, so I just wanted to mention that up front. So the next thing about observability in software is that arbitrarily wide structured events are the foundation of everything. What that means is that your event needs to be structured into key value pairs. JSON is a very common structure for these events. And your event should be able to include as many fields as you need to give you clues as to what's going on when something breaks later down the road. Once you have structured events, you can string those together into what's called a trace. Ideally, your trace will represent a request from the start of your system and all of the places that it goes within your code base until it ultimately returns the end result. So here we have an example of both an unstructured event, also known as a log, compared to a structured event if we were trying to create one based on this talk that is happening right now. So we've got the log on the right and then the structured event on the left. We have the same information on both sides. We've considered the details that we might care about later on and included them. The main difference is searchability of this data later on. With logs, you are generally going to need some kind of bash skills to get what you need out of them. And even then, you're probably still going to need to have a rough idea in your head of what the structure of that log looks like. But with the structured log, if you're pushing it to an observability platform that gives you the ability to filter by these key value pairs, then you could just pull up any talks with a speaker of Brooke Sargent or any talks that have happened within Columbus, Ohio. Earlier I mentioned stringing events together into traces. To elaborate a bit on tracing, a trace ideally represents a single request coming into your system and tracks its journey and the different code paths that are executed. A trace consists of a tree of spans, and spans are essentially our structured events. All of the spans share a trace ID that is a unique identifier connecting the structured events to say they're all part of the same request. To give a visual for traces, this is a waterfall view of a trace in Honeycomb. If you look too closely, you will notice that I originally gave this talk at an Animal Crossing conference, so some of the trace names are related to items in Animal Crossing. But anyway, each node represents a span, and the top span is called the root span. So looking at that root span, we can see how long the entire trace or request took, and then we can see each individual function call nested beneath and how long each of those took. And if we were to click on one of those spans, we could see the structured event and all of the detailed attributes associated with it. So here's a quick recap of some of the terms we have used so far and other terms that are used very frequently when talking about observability that might come up later on in the talk. So telemetry is the data emitted from a system about its behavior. The data you get from making your system observable is telemetry data. To instrument is to add signals to your code base that allow it to emit telemetry data. Commonly, you'll hear people say they're instrumenting their application or need to think about instrumentation, and that means they are using SDKs and tools to send off custom spans and traces that will help them when their system inevitably breaks. And spans and traces, as we have talked about, but as a refresher and to have a nice short definition, spans are units of work that combine to make up a trace. If you don't connect spans together with a trace ID, then they are simply structured logs. And a trace records the path taken by a request from start to finish. Here I'll briefly explain OpenTelemetry, or OTel, as you might hear it referenced. It's the open standard surrounding telemetry data. There is a lot more to it, and we could take up an entire talk diving into all of the details of OTel. But as an overview, OTel emerged as a response to a ton of different observability vendors implementing telemetry data structures differently. So it was a big investment to leave one vendor for another, or even if you wanted to use multiple vendors for different purposes within your system. You had to spend time understanding each implementation, and if you wanted to switch, you had to throw away a bunch of your code and re-implement it with new structures. So OTel is open source and vendor neutral. And there are many different SDKs and toolings for different databases and languages and things like that to help you instrument your app and generate telemetry data within your code base. If you are just getting started with observability, I highly recommend using OTel tooling rather than vendor-specific tooling to give yourself the most amount of flexibility. If you're still wondering why observability is important in software engineering, it's because we as software engineers are responsible for writing and running a lot of software. It has reached a point where we might work on several different systems for our jobs. And even if we just work on one system, it's probably a pretty large one. And these systems then reach out to other systems that you need some level of understanding of to be able to work with them. It's too much complexity to reasonably hold in our heads and understand exactly all of the logic paths and error states that are possible. There's a theory in psychology called the new theory of disuse that states memories evaporate from the brain over time if they're not used. So if you have a system that gets built but doesn't get updated very often, the knowledge of that system deteriorates as engineers shift their energy to other efforts. But a practice of observability helps those engineers to leave behind enough breadcrumbs to refresh their context instead of starting from next to nothing. Observability allows you to operate your system with excellence without holding an exact mental model of that system in your head at all times. So we've covered the basics of observability, and now I want to tell a story about a team who went on a journey in adopting observability and how developing a practice around observability shifted their team culture. So we start with a team of 4 engineers. We'll just refer to them as the Avengers for the purpose of this talk. So the Avengers have been asked to build a connected device platform for their company. The goal of the platform is to allow devices and apps to stay synced up with the same data. The team thinks this sounds like really interesting work, and they accept the mission. They want to build a really strong platform and knock their deliverables out of the park. So the first thing they did was get together to talk about the standards and best practices they wanted to follow while building this platform to make it the best they could. They settled on the following standards. Code gets to prod in less than 15 minutes once it's committed against main. 70% or greater unit test coverage is required before merging a PR or pull request. End-to-end canary tests run on core code paths a few times per hour and proactively alert on errors. And team members merge small, frequent changes to keep diffs manageable. The Avengers were feeling pretty good about themselves after agreeing on this list. Most of them had worked on legacy systems before, where these things were either an afterthought or not included at all. They wanted to build a better system. Despite setting those standards and holding each other accountable to them, the more engineers that onboarded to the team and the more features and complexity they added to the platform, things got more painful to operate and understand. When discussing that pain as a team, there were 2 main sticking points they felt they needed to resolve to hold true to that promise of building a better system and a better way of doing things than they had experienced on previous teams, and those were confidence in deploys and time to resolution. When the team had a retrospective to talk about all of the struggles they were having solving bugs as quickly as they wanted to and were expected to by their company, there was a lot of chatter around their logging solution, which was CloudWatch logs. It wasn't easy to correlate a log to a problem at hand, let alone correlate multiple logs across multiple Lambda functions to create a full picture of what might be going on. They felt that relying only on logs to operate their platform to meet their own expectations and the expectations of other teams in the company was not setting them up for success. A few members of the team had been hearing about observability, and the benefits they'd heard about sounded like it might be able to help resolve their pain, but they still didn't know what it meant to have observability or how to get started. So they went off and did some research, and this is what having observability meant for them. They added tracing to their code, starting with the most important service first, and then carved out dev cycles in each sprint to add traces to at least one more service until each service was instrumented. Each function call in a service got wrapped into a span that had attributes the engineers thought their future selves might care about when debugging. They invested in a tool to help with visualization and discoverability of the telemetry data. In this case, they chose Honeycomb. This tool displayed their traces in multiple spans as a waterfall, so they could see how the code was executed, how long each function call took, and the actual data associated with each function call in production. And most importantly, they added an ongoing practice of observability to their code review process and held each other accountable to answer the question, how can we observe this in prod before shipping new features? So this is, again, that same example of what a waterfall view trace looked like, and this is what they had for each of their services once they had finished implementing them for tracing. So if they wanted to know the count value in each of the get current count executions, or who exactly on the wait list was notified that their item is back in stock, it's right there, one click away. Over the next month or two, confidence in deploys increase, and every team member, regardless of experience level, can jump into debugging, finding answers much more quickly than before. The pain they were feeling is lifting. But most importantly, now that the team has an observability practice in place, there is a noticeable shift in their culture. So now I'm going to dig a little bit more into how observability contributes to a stronger team culture, and we'll still reference back to the team from our story. We left off the story with a shift in culture. The way it shifted was from a knowing culture to a learning culture. What does that mean? In a knowing culture, people are doing the same thing over and over again and know exactly how it's going to go as a result. Confidence is gained from repetition. In a learning culture, it's more common to do things you haven't done before, but with the confidence that you can observe and measure how it's behaving and adjust as needed. Work in learning cultures is approached much more like a bunch of little experiments. Like observability, there are a lot of definitions of culture of learning floating around, but this one is my favorite. A mindset within an organization where learning and improvement are at the heart of how people prioritize their time, do their jobs, and interact with one another. In chapter 10 of the book Accelerate, which is a fantastic book about high-performing teams and behaviors that separate high-performing teams and low-performing teams, it is stated in the section on organizational culture and identity that the best thing you can do for your products, your company, and your people is institute a culture of experimentation and learning. And observability is a practice that will help you do that. Now I want to share some qualities that are core to a culture of learning and how practicing observability contributes to building these qualities on engineering teams, as well as other things teams can do outside of observability that exhibit these same qualities that will strengthen your team. So first we have make learning habitual. Like I mentioned earlier in the talk, a really important part of implementing an observability practice is baking it into the processes that work for the team. The Avengers made sure that asking how to observe a feature was part of their code review process, as well as actually going and observing it post-merge. It became a habit within the lifecycle of a feature, and it allowed the engineers to make any necessary adjustments before calling a feature done and moving on to the next piece of work. This is one example of learning being habitual, but it can be habitual in other ways too, such as normalizing sharing what you've learned when you make mistakes or when a faulty deployment occurs with the rest of your team, instead of trying to pretend it didn't happen. Next, we have reward curiosity. Good observability tooling does this by ensuring information is at your fingertips, and every time you ask a question of your system, you're quickly rewarded with information and being at least one step closer to an answer or a solution. Other ways this can be modeled on engineering teams outside of observability is engineers of all levels being comfortable admitting when they don't know things and asking questions to fill in those knowledge gaps. This behavior can go a long way in shaping junior engineers to see people who have been promoted and climbed the ladder to senior, staff, and principal levels admit they don't know something and still have that curiosity to ask questions and learn rather than pretend they have all the answers. Value progress over perfection. Rewarding and valuing progress is a way to encourage learning. Without being trapped by the rigidness of perfection, a team can be much more exploratory and take risks that can lead to really big wins. The practice of observability demonstrates progress because you don't need to know every attribute you want to track up front. It's a journey. You start with the attributes you think your future self will want to know about, but if in the middle of solving a problem, you wish you had access to a couple of other attributes, you can just add them. As you and your team practice observability, you'll get better at it, and your system will become more and more observable as a result. This quality can also be shown through size of deploys. Earlier, when talking about the standards the Avengers agreed to, one of them was small, frequent deploys. Being able to sense when a feature adds value and merge it rather than waiting until it is perfectly baked and matches your vision exactly is a superpower. And finally, make learning social. Learning should be something your team can do together. This manifests through observability and having links to interesting graphs and queries to share so problem solving and debugging can truly become a team sport. With this capability, even remote teams can look over each other's metaphorical shoulders and build on what their teammates have discovered to reach a solution quickly. Outside of observability, having lunch and learns and hack weeks can be great ways to socialize learning on your engineering team. These commonalities between learning culture and observability culture means that practicing observability improves your team's learning culture. And because of that, every member of an engineering team benefits from observability. To showcase that, I want to highlight a few different archetypes on the engineering team from our story and talk about how they specifically benefited from this observability journey the team has gone on. First, we have Tony. He is a senior engineer who has been recruited to join the Avengers. He has quite a bit of experience coding and working on systems, but hasn't worked on a team with a strong observability practice before. And honestly, he's been kind of cranky about the idea of observability, thinking that, logs are fine for him. He doesn't really understand why you need this new technology. So he's pretty new to the concept of observability in general. And what he noticed through his onboarding process is that he's able to get up to speed faster than usual onboarding to teams. Having a tool where he can see traces, how services interact, and the schema of the system helps him assemble a mental model so he can begin contributing. Having fresh eyes on system telemetry data also means he can point out things that don't make sense to him, but the rest of the team has already been seeing as normal and help solve bugs with only a couple weeks on the team under his belt. He's also able to work on different parts of the system with relative ease, using the telemetry data as a compass to get himself oriented and understand the attributes that are important and the general flow of information through the system. As he onboards to this new way of working, He also learns to share context with his team members by instrumenting his own code, so anyone on the team can understand what's going on when it breaks, not just him. Next, we have Natasha. She is a mid-level engineer who is eager to learn and level up in her software engineering career. She was on the team prior to the push for observability, and once distributed tracing was added, and she learned how to explore the data in Honeycomb, she felt far more empowered to jump into investigating bugs and outages. She used to only feel helpful troubleshooting problems she recognized and had experienced before. But now with observability tooling in place, she also feels helpful figuring out brand new errors as well. As a result of jumping into solving so many new problems, she is able to level up in her career faster than she would have on a team with no observability practice, because she wouldn't have had the confidence or the right tooling to solve those same problems. She's able to gain context and learn from senior engineers like Tony through the instrumentation that they place in their code. Then there's Bruce. He's been brought onto the team as an apprentice after teaching himself to code for a few months. He will be on the team for 6 months to learn how to be a software engineer and launch his career in tech. He has a lot to learn, and while how to instrument code and the jargon around observability feels a bit confusing and overwhelming to him, he's still able to reap the benefits of the instrumentation the team has put in place. He was chosen as an apprentice because of the curiosity he exhibited, and Honeycomb is the perfect place for him to ask endless questions to learn and satisfy that curiosity. He feels like it's the Stack Overflow of the actual system he is working on, and loves having a visual way to understand how data flows through the system. Not to mention, he has a place to independently ask questions and be curious, on top of having senior engineers around to ask questions of and help him make sense of the telemetry data he's looking at. He doesn't think he would have been able to ramp up on the system as thoroughly or effectively if he was left to shuffle through CloudWatch logs to figure out how things worked. The impact of a team having a strong observability practice doesn't necessarily stop with that team. In bigger organizations where not all teams have the same standards and tool sets, one team's telemetry data can also benefit other dependent teams. In the case of our story, the Avengers were building a connected device platform, so any teams building apps or firmware on top of that platform stand to benefit from insights into how the platform is behaving. The final archetype we will talk about today is Gamora, an engineer on the Guardians team. Their team is building an app that sends data to the Avengers platform, and they haven't yet gone on their own observability journey. One of the features of the platform is to validate incoming data that has been sent and reject it if it's outside of the boundaries agreed on by the two teams. To help the Guardians understand what is wrong with data they've sent that has been rejected, the Avengers provide them with a developer dashboard that shows a table of relevant telemetry data that hit the platform, so the Guardians can have a quicker feedback loop and efficiently fix the data problems. Having this data as a common language between the teams also helps communication about problems in the system go much smoother, because it becomes less of a blame game with data to show clearly where the problem lies. The Guardians are also able to learn observability implementation tips from the Avengers, so they can get more visibility into how their app is operating and potentially even connect their client-side requests to the platform requests for an even fuller trace. So this brings me to the end of our story about the Avengers platform engineering team and their observability adoption. They were able to learn and grow and successfully meet the business goals they set out to achieve, in large part because they had an observability practice to help them both with solving technical problems and fostering a strong, curious team. A few takeaways are that the foundation of an observability practice is structured events. buying a tool is not observability. Observability becomes a superpower when it is successfully embedded as a practice into existing team processes. Observability benefits every engineer on the team, and possibly even engineers outside the team, not just the most senior engineers. Here, I just wanted to share a few resources for getting started with observability and OpenTelemetry if you're new to it. I know it can be overwhelming at first, but starting from that solid foundation of structured logs and then connecting them with traces and taking it one service at a time will get you on the right track. I'm also linking the book that I mentioned, Accelerate. I really think it is a must-read for all software engineers. And I'll make sure to share these slides in the Discord channel for this talk if anybody wants to access them afterwards. So thank you again for attending my talk. Here's how to find me on Twitter, where I sporadically hang out at this point. And I'm happy to take any questions with the rest of the time.